Okay, so now is the other special right triangle we're going to learn, and that one has an angle configuration of 30, 60, 90. Um, so it's a little more complicated than the 45, 45, 90. We have three sides, and they're all different, different lengths. So we classify them by a short side, a long side, and then the hypotenuse, which of course we all know is the hypotenuse is always the longest side, and we'll talk about why that is. So if we look at our notes, in a 30, 60, 90 triangle, the hypotenuse is twice as long as the shorter leg, and the longer leg is square root three times as long as the shorter leg. All right, the hypotenuse equals two times the short leg. The longer leg equals shorter leg times the square root of three. All right, so from previous lessons, we learned that the side lengths correspond to the angle that is opposite to them, and vice versa. So the side length that is, or the leg that is opposite the 30-degree angle, is going to be shorter because there's less angle opening up here. So this is what we call the short side. The leg side that's opposite the 60-degree angle is what they're calling the long leg of the triangle. And of course, the 2x, the side opposite the right angle, is the hypotenuse. All right. So as you can see from the theorem, we have a template just like the 45, 45, 90. This one has an x times square root of 3, and then a 2x for the hypotenuse. So there's three different rules here we need to remember when we're solving uh, right triangles using this configuration for 36 and 90. All right, so let's go into example 4. And it's kind of a good example because they're trying to get you to derive this, but I'm going to take it a little bit further and show you how it's all derived into what we get here. So the logo on the recycling bin at the right resembles an equilateral triangle with a side length of 6 centimeters. What is the approximate height of the logo? Find the area. All right, so I'm going to trace out what they're trying to say. Inside that recycling bin logo is an equilateral triangle, and that's kind of what I just outlined on the bin for you. All right, so let's see what they're talking about. All right, off to the right here. So if I take an equilateral triangle, all right, we know that all the angles in the equilateral triangle are 60 degrees. Um, we also know that all the side lengths are the same length. So if we take and drop a perpendicular bisector, um, that means it intersects the bottom of the triangle at its midpoint, leaving two congruent spots on it. So let's make that x and this x, which means we have a side length of 2x. So these together make 2x, which means all the other sides are also 2x. Now the 60-degree angle here, since it's bisected, is now 30 on either side. Okay, so now we see where the 30, 60, 90 comes from, the angle configuration, and we have two of the rules already in here. So let's pull one of the halves of these out, um, and we get this right triangle. 30 degrees, 60 degrees, of course the 90. We already know this is side length x. We know that this hypotenuse is one of the sides of the whole equilateral triangle, which is 2x. And the longer side is the altitude or the height um, here. So we'll call that the height. All right. So we're going to use to derive the rule for the height there. All right, so this is make that A, make that B, this is our C. All right, so A squared is X squared, B squared is H squared, and C is 2x squared, all in parentheses. Can't do much with the left side yet. 2x squared is 4x squared. Okay, be sure to square each part in the parentheses when you have a squared. We're going to subtract an x squared from both sides to isolate this h. Alright, 4x squared minus an x squared is 3x squared. Then we're going to square root both sides to get rid of the squares. So we get h equal to square root of 3 times the square root of x squared. And from the previous examples, we know that the square root of x squared is x, and the square root of 3 goes behind. Alright, so that is the height, and that's how we get the long side to be x times the square root of 3. And this is exactly how the 30, 60, 90 rules are derived. So the 45, 45, 90 is derived from a square. The 36 and 90 is derived from an equilateral triangle. Alright, so back to the problem. So we essentially have the same type of problem. We have half of this equilateral triangle. We have 30, and then we have 60. It's 2x. Has a side length of 6 centimeters, excuse me. So 6 centimeters. Alright, so since we know the hypotenuse is twice the size of the short leg, and we know the short leg is half the size of the hypotenuse, then we know the short part opposite the 30 is 3. And if you remember our rule for the long side, which is x squared root 3, x is the short side, and since the short side is 3, we simply substitute the 3 into the x for the rule of x squared root 3 on the long side. So we have 3 square root of 3, and that would be the height of this triangle. So now that we have the height, we can find the area. Alright, so base, we'll make the base 3. The height is 3 square root 3 over 2. Should be A equals. So, multiply this out, we get 6 square root of 3 over 2. 2 goes into 6 3 times, so we get 3 square root of 3 as our area, centimeters squared. And that answers the question. Alright, now on to example 6. It's a good example because you have to know when you're going to use the 45, 45, 90 or the 30, 60, 90 special right triangles. So this is good. So we have this picture. We're going to use angle 1 as a 45-degree angle and as a 30-degree angle, and we'll take it by case. So I'm going to delete here for some room. Alright, so let's take case A. Alright, so measure of angle 1 is 45. So if this is 45, the other side here has to also be 45. Alright, so we want to remember our rule for the 45, 45, 90 triangle. X, x, x squared root 2 for the hypotenuse. Make that better. So you should always have this around so you can look at it. Alright, so we want to see how high the kite is tethered to this 100-foot long string that makes up our hypotenuse. So we know that the hypotenuse is x squared root 2, and we have a kite length of 100. So we know that the 100 feet has a square root 2 in there. Alright, so the 100 feet should equal x square root 2 as our rule for the special right triangle. So we're going to divide out square root of 2 both sides. Multiply by the conjugate, cannot have a square root 2 in the denominator. Alright, so we get 100 square root 2 over 2, because square root 2 times square root 2 is 2. That's going to equal, we know 2 goes in 100 50 times, so we get 50 square root of 2. That's equal to our x, our height. That equals the height of the height for the 45 special right triangle. So just to label the side so we can see it. To both sides. Alright, so let's do case B as angle 1 being 30-degree angles. A 30-degree angle. So clear some space. You'll find this one a little bit easier. So depending on what side you're solving for and what the numbers are, they can be really simple, and this one's going to turn out to be really simple. So we take angle 1 as 30 degrees, which means this angle here has to be 60 degrees. Alright, so label the sides. So opposite the 60, this will be the long side. Opposite the 30, this would be the short side. Okay, and of course this is our hypotenuse. There. Okay, again we're trying to solve for the short side, which is x. So let's draw a little picture of our 30, 60, 90. So x square root 3, 2x. Now remember that when we write a rule, we have to orient it to where the situation we're talking about here. So if you look at the left side of the triangle, here I have x square root 3, which is the rule for the long side, and I have short written on the picture. So be sure that we're corresponding the correct angles. Notice the 60 is on top in this picture, my 30 is on top in this one. If you want, you could redraw the triangle to reflect your picture. So where this one will be 30, excuse me, just make a longer side there. Alright, so this will be your 60, 90, and then your 30 here. And then you can go ahead and draw your rule that matches your situation better. But either way, be aware of where your short and long sides are. Okay, so if we have a hypotenuse, this is 100, and we know the hypotenuse is twice the size of the short leg, or half the short leg's half the size of the hypotenuse, well, we just simply take the 100 and divide it by 2. So 100 equals 2x, which is the rule. Okay, to solve for x, you divide both sides by 2. That's why you would divide by 2. And we get x equal to 50. Now remember, this is the short side. Alright, so this would be, excuse me, having some difficulties here. This would be 50 feet. Alright, and that'll be the height there. So real easy. Do we need to find the long side? No, because we just want